Good morning. We're going to be working with transforming exponential and log graphs today. We're going to start off by graphing 2 to the x. This is an exponential equation. The parent equation is really, for this, is actually going to be y equals b to the x. That's base to the x, because that 2 can be different numbers, and we'll talk in just a minute about what those different numbers would do. So first off, I'm going to think about this in terms of a table. If I put in -2, -1, 0, 1, and 2, negative exponents, because these would go in for x, 2 to the -2 would be the same as 1 over 2 to the +2. So this is going to be 1/4. This is going to be 1/2. Anything to the 0 power is 1. 2 to the first is 2, and 2 to the second is 4. So I'm going to graph those points. -2, 1/4, 1/2, 1, 2, and 4. So what's going to happen in this, as I continue further out here, is this is going to create an asymptote, because these fractions are going to get tinier and tinier and tinier, but they're never going to get to 0. So that's going to go, whoops, along here, and then it's going to start shooting up pretty quickly. I'm going to draw in that asymptote and tell you the general equation here. The general equation, y equals base to the power of x minus h, and then plus k. For the purposes of this class, we're not going to deal with the change in a in the exponential and logarithmic graphs. It kind of goes beyond what we need to know for this class. But a couple things that I want to point out about this. First off, the distance here is always going to be 1. And this is actually our HK, 0, 0. That is our HK. So our actual graph isn't going to go through HK. We're going to go to the HK point, go up 1, and that's going to be one of our first points. The next part of the equation is to go over 1 and up the amount of the base. So, sorry, trying to figure out my colors here. So this is always going to be 1. This value, or this distance, is always going to be whatever the base is. So working from that, we also know this asymptote is going to be at y equals whatever the k value is. All right, so I want to look at the difference between 2 to the x and 5 to the x. Those are their different bases. 2 to the x we know has 0, 1, 0, 2, or sorry, 1, 2, and 4. And then it goes back, gets smaller, smaller this way. So, whoops, that's messy. Something like that. 5 to the x, my fractions are going to get smaller quicker. It's still going to go through 0, 1, because 5 to the 0 is 1. 5 to the first is 5. And then 5 to the -1st is 1/5, so these fractions get smaller quicker, but they still never going to get to 0. So the difference that we see here in these two graphs is that second step over, the ones that you have to show in your graph. So this distance is still 1 on both of them, but when I go from the locator point, remember that's our 0, 0 in this particular case, but that will change as we transform them. We go over 1 and up 2 because our base is 2. On this one, we go over 1 and we go up 5 because our base is 5. Our asymptote would stay the same. So if we're looking at how to actually transform these, we know a couple of things. We're going to have an asymptote at y equals 3. So I'm going to draw that in. And I'm going to write that down as an instruction. All right. Then I'm going to put an x at my locator point. My locator point is the point 6, 3. Remember, h is always the opposite of what you think it's going to be. I'm going to put that in green as well. So the point 6, 3 and then write that instruction. The next thing I'm going to do is I'm going to go from my locator point. That used to be the 0, 0, and I'm going to go up 1 because there's always a point 1 up from that locator point. That's my first very important thing to put on my graph, other than my asymptote. So, next, I'm going to go back to my locator point, and I'm going to go right 1, and then I'm going to go up whatever the base is. And I'm going to make a point. So this is a base of 2, I'm going to go up 2. And then the last step is to draw the graph. So I start low, going in from the left, and I'm going to go up. So I want to point out the 3 distinct pieces of this that you have to have on the test. The asymptote, the horizontal asymptote for the exponential, the 1 point above HK, and the 1 point to the right of HK. So most of the time we get used to going from the first point we make, we go like with the parabola, we went up 1 and out 1, out 1 and up 1, out 1 and up 3. We're not going to go from this point to make this point. We're going to go back to HK, go right 1, and then up whatever the base is. So make sure you make that distinction when you're doing this. So this one, I'll just go through the process real quickly. -2, my asymptote. I have a locator point of -5, -2, so there's my x. Up 1 from x, back to my locator point. So back here, over 1, my base is 3, so I'm going to go up 3. Come in from the right, in from the left. Wow, let's try that again. And go up. And that's my graph. Now we need to look at the log graph, which is the inverse of the, which is the inverse of the exponential graph. This one has a base of 2. Normally it's just base b. The general equation is going to be y equals log base b x minus h plus k. So this one is going to be a little different. All the points on here are, because this is a base 2, it's going to be the flip of our, it's going to be the inverse of our 2 to the x. So we had a point at 0, 1, so that means we're going to have a point at 1, 0. We had a point at 1, 2, which means we're going to have a point at 2, 1. Our asymptote was at y equals the k value. Now it's going to be at x equals the h value. So you're going to have a vertical asymptote with a log graph. And those are the 3 important parts of this. The process is going to be really similar, except we're going to start from the bottom, go out to the right. So that's our log base 2 graph. So if we're looking at this process, again, we're going to start here with a vertical asymptote. So I'm going to put that asymptote at x equals 2. And I'm going to make an x at my HK point, so 2, 3. From 2, 3, I'm going to go right 1 and make a point. I'm going to go back to my locator point, and I'm going to go up 1, and then I'm going to go over the amount of the base. Those are my 3 important parts, the asymptote and those 2 points on the graph. And then I need to actually make the shape of that graph. So let's solidify those instructions. Okay, so just to review those real quick, draw our vertical asymptote at x equals h. In this case, x equals 2. Remember, it's always the opposite of what you think it's going to be. Then make an x at hk. Go 1 right from hk and make a point. Go back to hk, go up 1, go right whatever the base is. In this case, the base is 4. So up 1, right 4, make a point, and then you're going to draw your graph. Function is going to go from bottom out to the right. Now, it's important to note with the log graphs and the exponential graphs, we don't have a change in A for the purposes of this class. So we're not going to be flipping it, anything like that. The exponential will go from left and go up. The log graph will go from the bottom and go out to the right. That would change in future classes when we start looking at different A values, but we're not going to do that in this, in the Algebra 3-4 class. So that's it for transforming log and exponential graphs. Have a lovely day.